Hey everyone, I want to do a little review with dimensional analysis for you all. We've all studied this before when we've been younger, but you might not be as comfortable with it or remember all the steps. So I just want to kind of walk through everything before you tackle your homework sheet. To start with, to get the ideas rolling, I want you to look at this following problem. If I asked you to do this calculation without using a calculator and only gave you 5 seconds, some people may take a step back and kind of shut down and say, whoa, that's a lot of numbers. But if you do take a step back and look at the whole picture, you might realize that certain numbers can cancel out. You might see that the 17 and the 32 and the 19 are in the numerator, they're both in the denominator position. And we might remember the rules in algebra says that if there's something in both top and bottom of a fraction that are common, we can cancel it out. That makes this whole problem easier because what's left is 4 times 2, and of course we know that would be 8. I want you to keep this in the back of your brain right now as we look at dimensional analysis, and we'll come back to this idea in just a little bit. So when we want to start the idea of dimensional analysis, we want to kind of just think about what exactly it is. Well, the reality is in science, we make measurements. And these measurements that we make about substances include two things: the number as well as the unit. And that unit means everything. It gives you the actual scale, the comparison that we need during the measurement. The reality, though, is when we make these measurements, the unit part of that measurement is subject to the same rules of mathematics as well as the numbers themselves. In other words, if we can simplify numbers like you saw at the start, we should be able to do the same thing with units to help us through the process of conversions, through dimensional analysis. So how do we go about doing that? Well, of course, to perform dimensional analysis, you need to have a series of conversion factors to help you. And a conversion factor is a ratio of two equivalent or related quantities, but they're expressed with different units. So you may know a lot of different conversion factors out there. For example, we can talk about 1 foot's equaling 12 inches, or 1 inch is 2.54 centimeters. And these are easier conversion factors because they both measure distances. A foot is a distance, as are inches. Inches and centimeters are all distances. These are equivalent distances overall. Sometimes a conversion factor might be something that relates to different quantities. For example, the density of water is 1 gram per milliliter. A gram measures mass, a milliliter measures volume, and they're not the same aspect, but we can use them interchangeably because there's a relationship based upon water. So these conversion factors, these relationships, we can use them or express them mathematically two different ways, with one value on top versus the other value. For the case of 1 foot and 12 inches, I could use this mathematically as 1 foot over 12 inches, or 12 inches over 1 foot, depending upon how the problem is oriented. And the reality is, when I see 1 over 12 or 12 over 1, mathematically these are two different values. But scientifically, these are equivalent quantities because that distance of 1 foot and that distance of 12 inches are the same. This fraction, scientifically speaking, is a ratio of 1, as is this version of it, though, because they're relating equivalent distances. And so when we use these conversion factors to change units, what's going to happen is we're essentially multiplying by scientific values of 1 just to change our units. We're not actually changing the value of the measurement, we're just changing units. So, what are we going to be doing overall? Well, during dimensional analysis, you are essentially going to be multiplying by these fractions, these conversion factors, in order to change your units. You want to arrange your conversion factors so that the units cancel out and your desired units remain in the very end. Sometimes it's very straightforward and easy, sometimes it might be more challenging, depending upon the conversion you're actually given. So that's the nuts and bolts to what's going to happen. Let's see one of these examples actually in action. Let's actually take a look at your homework sheet. We're going to work through the first problem together. So if you don't have it out, go ahead and take it out. I'm going to switch videos and get everything set up for you. All right, everybody. If you take a look at your homework sheet, we're going to work out the first problem over here together. The first question says, how many inches are there in 232 millimeters? So if we're looking at a problem like this, the first thing I always like to do is I always like to ask the question, how many inches? So I'm going to write question mark inches are there in 232 millimeters equals 232 millimeters. So here's what a lot of people have been taught when they're younger. They may not have been taught to add this piece to the left. You may not. You may have just said, hey, just start with the number that you have. We have this. Let's do some conversions. I was always taught to add this piece into it, and I actually like doing this. And the reason why is it helps guide you as you follow your steps. It lets you know what unit you're trying to get to in the end. Now, if you don't do this, it's not going to ding you. If you do it, it may be helpful to you, but I'm going to show it as if you like it. And so the first thing we want to do is we want to try to figure out ways to get from millimeters to inches. Now,
when we do conversions, there's a series of multiplication by fractions, as we saw in the earlier part of the video. And so you can write down your steps as the idea of multiplying by some series of fractions. This is the way that I was taught. That way it's comfortable to me. I can keep track of what's the numerator and what's the denominator position. But maybe not. Some people were taught at a younger age to do what they call the T-chart method, which is the exact same thing. It's just drawing defined lines of numerator and denominator. Whichever one's more helpful for you, please do so. It's not going to be any different for your final answer. So if we want to convert from millimeters to inches, we have to have some way of comparing these units. We have to have some set of conversion factors. What makes conversions hard for some people is the fact that sometimes these relationships are easy to find, sometimes they're not. Well, for these two units, what I've done already is I've actually thought about all of these different comparisons I can make. The first thing we see is that we're actually told that there's 2.54 centimeters in a single inch. And so that's one of 4 conversion factors that I came up with. 2.54 centimeters equals 1 inch. I also know that 100 centimeters are in a meter. I thought that might be helpful because if we're trying to get from millimeters into inches, and if this deals with centimeters, I got to get away from centimeters. I have to convert that to something else. So I thought 100 centimeters might equal 1 meter. I also know that 10 to the third or 1,000 millimeters are in 1 meter. Now I put a 4th conversion factor down here, and we'll talk about that a little bit later though, but some of y'all might know that 1 centimeter is equal to 10 millimeters. If you do, it makes your steps a little bit less, but if you don't, it's okay. And so what we want to do is we want to follow our units along the way. We want to keep track of what units we have and what units we're trying to get to. I know I have all these facts down here I can refer back to, but if I look back at my problem, the only thing I have to go from is millimeters. So whatever conversion factor I want to use first, the only thing I know definitively is that millimeters would have to go in the bottom to cancel out. That's the whole premise of conversions, that we're trying to cancel out our units. So if I look back at my conversion factors, the ideas that I came up with, the first conversion factor that I see that deals with millimeters is 1,000 millimeters are in 1 meter. Since we put millimeters in the bottom, I'm going to put 1,000 with it. I'm going to put the 1 meter on top. Now I'm going to cross that out because I've already used it. Don't need to worry about that anymore. But that setup will work for us because we are able to do this now. Now I want to look back at my units. A meter isn't the inch I'm looking for, so I got to keep going. I got to get rid of this meter. And so I look back down at my conversion factors and I try to see what involves a meter. And I see this conversion factor. 1 meter is 100 centimeters. I got to put my meter on the bottom because I need my units to cancel. And so if I look at this relationship, I want to put the 1 meter piece on the bottom and the 100 centimeters on top. I've used that conversion factor. I'm going to get rid of it. We were able to do that. And again, I look back at my units and I realize that we have now centimeters on the top, but I want inches. So we're not done. We have one more step we're going to add. And when I look back at this conversion factors, the relationships we have, what they gave us in the problem, though, is the fact that 2.54 centimeters are equal to 1 inch. What I know, though, is that a centimeter will have to cancel out here, so I know that centimeters will have to go in the bottom. And so when I look back at this, I know that 2.54 centimeters will go here. 1 inch would have to go on top. I've used that, and life is good. Centimeters are gone. When I look back at this, the only unit I have remaining is inches, and I want inches. And so all the work looks like it's set up properly. All we have to do now is just use the calculator. I'll mention this in class, though, but I like to, at least at the beginning of the year, to box in the units as I get to them. And the reason why is if I want inches and I see inches, I know that I'm done with my actual calculation. We'll see what happens when you have units on top and bottom, keeping track of multiple steps later, but it's helpful for some people just to know that you actually have finished the calculation this way. Now, to do this on the calculator, a couple different things you can do. What I find the easiest for people to do is I like to do just a set of parentheses. We have a couple numbers on the numerator. We have a couple numbers in the denominator. No matter conversions, what I think is easy is to do a set of parentheses and multiply everything that you have across the top. So I'll do 232 times 100 times, well, it's 1 in the end. You don't need the 1, so I'll actually get rid of that. You can add the 1, it's not going to change anything. But I want to put everything in the numerator together in its own set of parentheses. I then want to divide by, in a new set of parentheses, I want to multiply everything across the bottom. In this case, it's 1,000 times 2.54. And that's going to ensure that we don't have any issues with order of operations. That tends to become apparent when people have scientific notation involved, but when we plug it in the calculator like this, we get an answer of 9.13385826772 and so forth. For significant figures, if we think about all the math we did here, all we did was multiplication and division. And the rules for multiplication and division say that you round to the least number of significant figures used. Well, the idea here, though, is that these conversion factors are defined quantities. There's exactly 100 centimeters in 1 meter. There's exactly 1,000 millimeters in 1 meter. We know these ideas definitively. So the only uncertain number that we have, though, is that 232 millimeters that we started with. If that has 3 sig figs, my answer can only have 3 sig figs. And so I would report my answer as 9.13 inches. And again, for good measure, we'll just box the final answer and let me know that we got there. But that's the answer. Now, I mentioned earlier that you may know another fact. You may know from the get-go that 1 centimeter is equal to 10 millimeters. What that can do for you is this step right here can be condensed. If you knew that 10 millimeters is 1 centimeter, you could have done in one conversion factor this. And it would go in place of these two factors here. And if you look at the numbers, 100 over 1,000 simplifies down to 1 over 10. You're going to get the same answer. So if you knew that or can think about that, great. If not, one extra step's not going to hurt anything. All right, everybody, go try the rest on your own. Good luck with them, and we'll talk more about it.